Okay, so this is a video about the parent functions. A family of graphs displays similar characteristics. A parent function is the simplest function of the family. So there are 9 different functions that we're going to look at. First of them, which you're familiar with from Algebra 1, is the linear, which is f of x equals x. It is the line that passes through the origin and continues on to infinity. So our domain is from negative infinity to infinity, or all real numbers. Our range is negative infinity to infinity, or again, all real numbers. And again, you figure out domain by looking for going from left to right for domain and up and down from our bottom to top for range. So if I go to the very far end of this block, the very first thing I see is an arrow, which tells me negative infinity because it's on the negative side of the x's. And then I move over, and I find another arrow, which is on the positive side of the x's, so it's positive infinity. I do the same thing with range. First thing I come to is a arrow, and it's on the negative side of the y's, so that's negative infinity. And then I continue up, and I come to another arrow, which is on the positive side of the y. So that's why I would get negative infinity to infinity for both. The x-intercept is where the chart actually crosses the x-axis, and in this case, it's at the origin. The y-intercept is, again, where does it cross the y-axis, and that is, again, at the origin. Now, I can shift this line up and down, left and right, but I will always only have one x, one place where it could cross the x-axis. End behavior involves looking at what are your x's doing, and when based on what they're doing, what's going to happen with your y. So we always look at the furthest out from least to greatest. So as our x approaches negative infinity, so as it moves further and further to the right, or to the left, what is my y's doing? Well, my y's are moving down to negative infinity. As I go to the right, as my x's get bigger, my y's are going up. So that moves from infinity. As x gets closer and closer to infinity, y's get closer and closer to infinity. And because this does not have a break anywhere on it, that is continuous. Okay. So the next one is the absolute value, which is f of x equals the absolute value of x. And remember that with absolute value, it makes anything you stick into the x, the absolute value causes it to become positive. So it doesn't change its sign, it just makes everything positive. And its graph starts at the origin, and as x approaches infinity, y approaches infinity. As x goes towards the negative, y goes to the positive. Okay? So our domain is, as you're walking from left to right, we come to an arrow, which is negative infinity. And then we keep going across, and x becomes positive infinity. Now with our range, we have to start at the bottom. As we go up, the very first thing we come to is at 0. And it is existing, so we have a dot there. So we have a bracket 0 to infinity. Or x is greater than or equal to 0. That's another way we could write it. So it's all real numbers for domain. X is greater than or equal to 0. X-intercept is at 0, 0. Y-intercept is at 0, 0. And if we were to shift this down, it could potentially have 2 zeros. So if I took this and shifted it down a little bit, say 1 down, it would cause there to be 2 zeros. So the maximum number of zeros x-intercepts is 2. As x moves closer and closer to negative infinity, you can see that as we go this way, the y's keep going up. So that makes that to infinity. As we move to the positive, the y's go to positive. So infinity, infinity. And again, this is continuous because there's no break in it. So our next one is quadratic, which is again back from Algebra 1. F of x equals x squared. And this one kind of looks like a U. Easiest way to start is start at your origin. 1 squared is 1. 2 squared is 4. Negative 1 squared is positive 1. Negative 2 squared is positive 4. And that gives you your basic shape. Okay, so our domain is as you move from left to right, we come to an arrow, so negative infinity. And then we get to a second arrow, which is infinity. Range is again very much like absolute value. We come up and the very first thing we get to is 0. So it is inclusive and it's moving off into infinity, on both arrows. So our x-intercept is at the origin, 0, 0. Y-intercept is the same. And again, if I take this image and I pull it down, I could potentially have 2 places where it could cross. Also, it could be 0, because if I push it up, nothing could cross. The same thing with absolute value. So the maximum number of roots or x-intercepts you can get is 2. Now, as your x goes further and further to the left, your y's are going further and further north. So that makes that as x approaches negative infinity, y approaches the infinity. As x approaches the positive infinity, again, y goes to infinity, and it is continuous. Our next one is cubic, which is f of x equals x cubed, and I apologize for the dog sounds in the background. So always start at the middle. So if I did a real quick t-chart, x is 0, y is 0 cubed, which is 0. Negative 1, put negative 1 in there, we get negative 1 and then we put positive 1, and we get 1. We kept going out, negative 2 and 2, we get negative 8 and positive 8. So our chart only has up to 5 on both sides, so we're going to kind of estimate this at 1, 1, and then 2, 8, and then negative 1, 1, or negative 1, negative 1, and then negative 2, and negative 8. So that gives us an idea of what it should basically look like. Okay. Our range is negative infinity to infinity. So as we move from left to right, we come to an arrow, and then we end up in an arrow with range, bottom to top, arrow, and then we end in an arrow. So negative infinity to infinity, which again is all real numbers. Anytime we have negative infinity to infinity, it's all real numbers. Okay, x-intercept is at 0, 0. Y-intercept is the same. Now, if I was to shift this or widen it, it's possible that this thing could get wide enough that there is 3 different places where it might cross the x-axis. It just depends on how it's squished. So as x goes to negative infinity, what's going on? So we're moving left, and what's going on with our y's? They're going down, so that goes to negative infinity. As we go to the right, our x's are getting bigger, and so are our y's. And this is also continuous. Okay, now we're going to see some of the inverse functions, the square root, which is the inverse of x squared. And then the cube root, which is the inverse of x cubed. Okay, so f of x equals the square root of x. Another way of writing that is f of x equals x to the 1/2. Okay, and again, this is one where you would start at 0. Now, because x is under the square root, we cannot put negative x's in. It's against the rules. That makes it imaginary. We can't do that. So we're going to just use positive x's. So when you go to 1, square root of 1 is 1. Square root of 4 gives us 2. And I skipped over 2 and 3 because 4 is a perfect square and 2 and 3 are not. So now that gives me my basic shape. Okay. So our domain has to start, as we're moving left to right, it does start at 0. And it moves off into an infinity. For my range, also starts at 0 and goes off into infinity. The reason why we can't do the bottom side of this half smiley face on its side is because if we did, it would not be a function. We could draw the vertical line test, and this bottom area down here would make it a non-function, so we can't do that. So that's why I didn't draw it. And that's why the range is also limited by the 0 to infinity. Okay? My x-intercept is 0, 0, and my y-intercept is also 0, 0. If I was to move this down, it would only ever touch at one place. So that is the ones. Unlike on the quadratic where it can possibly touch twice, this will only touch one time. So as the end behavior, as x approaches 0, y goes straight to 0. As x gets bigger and goes to infinity, y also will go to infinity. But because it does have that stopping point and not 2 arrows, it's discontinuous. Okay? So for the cube root, f of x equals cube root of x, which is also written as f of x equals x to the 1/3. We're going to do the same kind of thing we did with the other one, put x and x to the 1/3 in here, and we're going to pick ones that are perfect cubes. So I'm going to pick 8, -8, -1, 0, 1, and 8. I did those because you can take a perfect cube root of those 5 numbers and it will tell us exact numbers. So perfect cube root of -8 is -2. Cube root of -1 is -1. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. And that gives us some starting points. Again, we're going to estimate on a few of them. So at -2, x is -2. As x is -8, which is kind of about here, we should be right about there. Right about there, actually. At -1, we should be at -1, 0, 0, +1. And then at x equals 8, right about there, we should be on the 2 line. So that's kind of the basic look to it. It's a little flattened, but it's the same idea. So we have -infinity to infinity for our domain, -infinity to infinity for our range, so all real numbers. Our x-intercept is still 0, 0 through the origin. And this one also, if we shift up and down, we'll only end up with one spot. Because as you shift, it's going up and down, left and right. It will stay one place where it's crossing, as opposed to 3 on its inverse. As x gets closer and closer to -infinity, our y's are going to go to -infinity because they're continuing to fall. They're just going to keep making this falling motion. As you go to positive infinity, our y's are also going to continue to grow bigger and bigger, which makes this continuous. Okay, so for reciprocal, we have f of x equals 1 to the x. Another way of writing this is x to the -1. Okay, so to draw this one, the key to it is what can we put into x? Well, the big thing that we know is you cannot divide by 0. So 1 divided by x cannot happen. So I'm not going to get a 0 in there, but I can put 1. If I put -1 in, I'm going to end up with -1. So 1 over -1 is -1. If I put +1 in, I'm going to have a 1. So that's our starting point. Now continue, think about it. So as I put x in, 1 divided by x, putting in 1 got me 1, putting in -1 gets me -1. But let's say I put 2 in. 1 divided by 2 is 0.5. -2 gets me -0.5. And as I keep putting in bigger numbers like 1/3, 1/4, 1/5, my 5, 1, 4, 5, 6, these decimals are going to get closer and closer to 0, but they never reach 0. So really, this is what ends up happening. You get that curve that's getting closer and closer to 0, and also the same thing as you start getting closer, the fractions. So you get bigger and bigger numbers, but you're still never going to get close to that 0. Same thing over here. Positive's going to go up, negative's going to come down. Okay, and what ends up causing that is what we call asymptotes. So they are imaginary walls on the y-axis and on the x-axis, that x equals 0 and y equals 0, that stops it from crossing over. And because the reason for that is because you cannot divide by 0. Okay, so our domain, therefore, is x cannot equal 0. And therefore, y cannot equal 0. The other way of writing that takes a little bit more room, which is why I did it below. We're going to go from -infinity to 0, and then we're going to skip over to 0, but not included, and then go to infinity. That will give me my domain. For my range, same thing. Going to start at -infinity, go to 0, but I'm not going to put a point there. I'm going to skip over 0 and then go straight to infinity. Okay? So there are no applicable x-intercepts, and none on y-intercepts. And if I was to shift this up and down or left and right, I would only cross the x-axis or the y-axis or the x-axis one time. So if I shift down, I will cross in one place, never two. So the maximum possible zeros that I could get if it was shifted is 1. Now, as our x approaches -infinity, my y is going to approach 0, but not actually get there. As x approaches infinity, my y is also going to is going to continue to go to is going to approach let's see, as x goes to infinity, y is going to approach 0. Yeah, that's what it was. Okay, and this is discontinuous because we do have that break at x equals 0 and y equals 0. Okay, I don't know where I stopped, so I'm going to have to edit this, but exponential is f of x equals b to the x, where b is 2, 10, and e. It is the inverse of logarithmic, so which is f of x equals log sub b of x, where b is 2, 10, and e. To do the exponential, you have to put in 0 for x, and that gives you 2 to the 0 power equals 1. So anything to the 0 power will always get you that first 1. That's your starting point. And then it basically continues up the bottom as it goes to the -infinity, approaches 0, because there is an asymptote on the x-axis. As it goes to positive infinity for x's, it goes to infinity. Our domain is -infinity to infinity, range is 0 to infinity. There are no x-intercepts because there is that asymptote. The y-intercept is at 0, 1, which is right here. If we do shift this down, you could get a maximum of 1 root, but it has to be shifted because the asymptote has to go down as well. In behavior, as x approaches -infinity, y will get closer and closer to 0, but not ever equal 0. As x goes to positive infinity, the x's will continue to get bigger, and it is continuous. There is a restriction of y as 0. And a way to remember that is which of these two had a restriction. This one did. It's the y, and it's at 0. So that's my asymptote's name. So logarithmic, you start at the opposite. So if this is at 1, 0, the logarithmic of 2, log base 2 of 0 will give you 1, or a 1 will give you 0. And so it will do the same pattern. It will, as you get x is closer and closer to 0, it will follow that y-intercept or y-axis at x equals 0. As it gets bigger and bigger for the x's, it will go to infinity. So our domain starts at 0 but doesn't include it, and then goes to infinity. Our range goes to negative infinity to infinity. We have an x-intercept at this 1, 0, and we do not have a y-intercept. The maximum number of roots that you can get x-intercepts is 1, because I don't care if you push this up or down, left or right, it's only crossed one time. In behavior, as x is approaching to 0, getting closer and closer to that origin, your y just keeps getting bigger, teenier and tinier to negative infinity. As x approaches infinity over this way, the y just keeps growing. So that is continuous, but there is a restriction at the y-axis. And again, x equals 0, the reason we call it that is because that's who had the restriction. It doesn't include 0, so that is my asymptote's name.